Hello and welcome to high voltage engineering. We are talking about generation of high voltage and current. In the previous class we have seen the generation of impulse voltages. Now we'll be talking about generation of impulse currents. So what about the generation of impulse currents? Where do you find these kind of impulse currents? Lightning discharges involve both high voltage impulses and high voltage current impulses on the transmission line. So both of these impulse voltage and current are I can see in the lightning. So protective gears like surge diverters have to discharge a lightning current without the damage. So these surge diverters, they divert this lightning. So we need to test these surge diverters, right? So therefore generation of impulse current waveform of high magnitude, that is more than 100 kiloampere peak, find application in test work as well as the basic research of nonlinear resistors. The electrical arc studies and the studies relating to electric plasma in high current discharges. So these are the requirements for the development of impulse currents. So the impulse current topic, we're going to look for three topics here. The circuits for producing impulse current waves. Then we talk about generation of high impulse currents, and then after that we'll be talking about generation of rectangular current pulses. Okay. So what about the circuit producing impulse current waves? The given by the circuit on the extreme left. Okay. So again it is in the RLC circuit. Okay. Now the impulse current, the shape is given on the graph that is in the middle. Okay. Now for that you can see the graph, the currents can be either of the form of type 1 or type 2. Type 1 is a damped oscillatory and the type 2 is over damped. So we have two kinds of current impulse current waves that is produced by the circuit on the left hand side. Okay. Now what is that? On the right hand side, these are the capacitor banks. We'll be talking about the capacitor banks. So these are the series of capacitor that are connected. So they are connected in parallel. You can see with flat strips. Okay, and they are connected together by hollow tubes. So for producing impulse current of large value, a bank of capacitors is connected in parallel and are charged to a specific voltage and discharged through a series RL circuit. So we have a bank of capacitor. Okay, a capacitor bank. So look at the circuit on the left hand side. You can see a capacitor. It is nothing but a capacitor bank, that is a capacitor made of number of capacitors. Now that is charged and then it discharged through the RL circuit. This is nothing but the basic circuit of the impulse current generator. So since the circuit is basically underdamped, the R by 2 must be less than root over L by C. Please remember this thing. And how this circuit is being analyzed is nothing but when you see the RLC circuits, you have the way it is, the other circuits have been calculated. This circuit also is calculated by the similar way. You write the circuit equation and you provide and you write the Laplace transform of it. Okay. Now, when you write the Laplace transform, you can get the circuit as an expression given by Im equal to V by omega L with an exponential of minus alpha t and sine omega t. So keep this equation in mind. This is how the equation is formed with impulse current generators. Okay, the alpha and omega values are given. Now for the impulse, the time taken for the Im to rise to from 0 to a peak value, that is the rise time, is given by this expression. You just you remember these expressions. The duration of half cycle of the damped oscillatory wave is T2, and the expression of T2 is to be remembered. So I want all of you to go through the calculation of these. Okay, you can find it in the book, and if you have any problem, please mention, because the calculation is similar to the all other calculations. Okay, now we'll come to the generation of high impulse current. For producing large current values of impulse current, a number of capacitors are charged in parallel and discharged in parallel into the circuit. So these are the series of capacitors, as I have told you, on the right hand side. So in order to minimize the effective inductance of the capacitor, divide into smaller unit. Now if the capacitors are big, the capacitors will also create its own inductances because it is connected via wires. Okay, so in order to reduce the inductance of the wires, it is divided into small units. If there are N1 groups of capacitors, each consisting of N2 units, and if L0 is the inductance of the common discharge path, and L1 is the inductance that each group, and L2 is that of each unit, okay, then the effective inductance is given by L0, L1 by N1 and L2 by N1, N2, N2. So these are the formulas you need to keep in mind. Okay. Next topic we will be talking about generation of rectangular current pulses. Okay, so what are these rectangular current pulses? Current pulses are in the form of this rectangle as shown in the graph below. So these rectangular pulses are created by circuits that has been shown here. So the generation of current pulses of high magnitude, that is a few hundred amperes, and duration up to 5 milliseconds can be done by discharging a pulse network of or cable previously charged. Okay, to produce a rectangular pulse, a coaxial cable of surge impedance L0 by C0 root over L0 by C0, where L0 is the inductance and C0 is the capacitance per unit length, is used. If the cable charged to a voltage V and discharged through a test object of resistance R, the current pulse I is given by V by Z0 by R. So what happens is that, how can we get the current pulse? We need either discharging of a pulse network or a cable. Okay, so we have a let's say we have for a rectangular pulse we have a coaxial cable of impedance root over L0 by C0. So L0 is the natural inductance of the cable and C0 is the natural capacitance of the cable. Root over L0 by C0 is nothing but the surge impedance. If the cable is charged to a voltage V and then discharged, then the current will be produced, that is Z0, V by Z0 by R. The V is the applied voltage. The pulse voltage RV by R plus Z0 is developed across test object R, and the pulse current is sustained by a voltage wave V minus IR. For R is equal to Z0, the reflected wave from the open end of the cable terminates the pulse current into test object, and the pulse voltage become equal to V by 2. Okay, so now let us understand what is going on here. So we have a pulse creating circuit. Okay, now this circuit has a surge impedance, that is root over L0 by C0. Now when this cable is charged and then discharged, we have a current that is given by V by the resistance R added to the surge impedance. Okay, So we can have now this current can be obtained via, if the voltage is a pulse voltage, the current will also be a pulse voltage. Okay, so a pulse voltage of RV divided by R plus Z naught is developed across the test object R. Okay, and the pulse current is sustained by a voltage wave V minus IR. So this is how, or this, you can see the pulse circuit, and this is how the pulse waveform is generated. Okay, so this is the end of the of this class. Thank you.